Okay, lab test number 1 on Thursday. I'm going to go over solutions to some exercises after class if you can stay, but I'm going to record anyway, but you're welcome to stay. I'm going to take a 5 minutes break after this current lecture, and then whoever wants to stay, stay. If you have to go, feel free, okay? And for lab test number 1, as you receive an email from our course director, Professor Ma, so the coverage is going to be utility methods, and also testing using JUnits, and also Javadoc. That's kind of the general coverage. But I would say you should really study the general coverage, but certainly you will see something similar to what we do as the additional exercises. Okay, that's what I can say. And then I'll try to be fair to both sections. Presumably the one on Tuesday have more time to study, right? So I will try to make sure everybody's getting the fair treatments. I'll try. Okay, so let's go back to our discussion about objects and classes. So we still got quite a bit to discuss. It's quite a challenging topic, I would say. Okay, let's try to work on some challenging examples. And we'll start with the slides, and then whenever I need to go to Notes or Eclipse, I will go. Okay. Okay, about the, so what we have gone through, we have talked about some very simple object orientation idea. Okay, so I think what I would do is I'll just start right away with this reference, okay, over here. Let me just review what this reference is. Basically, it talks about the context objects whenever you're trying to make a method call. I'll do another example together, okay? So now, let's say we have a point class over here. Remember the point class we talked about last time? Okay, so we have two attributes there. We got x and y, both being double. And let's say we have a method over there, and there should be a void, of course. That's a typo. There should be a void. Okay? Let's say we have this simple method here. Over there, you can see the definition. It has one parameter, double and units, and then y plus equal units. Okay? Let's try to work out what this is trying to do, because most likely for every method that you're going to define will be more or less the same. Okay? Maybe slightly more complicated than this, but let's try to understand the basics. Okay? So now I'm going to explain that on the iPad first, and then I will show you how you can use it. Okay? So now let's use our notes over here, and let's see what happens. Okay? So now, let's now just read, I'll just put the definition here again. So we have a class called point, and then we have two attributes and one method. Okay? So we have class point. Over here we have double x, and we have double y. Okay, two attributes. And we have our only method, which is mutator. So we'll say void and move up. And then we have some, let's say integer, just for simplicity, integer. And then I would say some units u. Over here, we're going to say y plus equal u over here. Okay, that's the only method we have. Let's also put the constructor inside to see how things will work together. Okay? We also have our constructor, which has the same name as the class, point, and then let's say have a new x and new y. So over here, I'm going to say integer, let's say double. Let's just be consistent with the type. Let's say we have double here, new x, and we have double new y. Over here, we simply say x is assigned to new x, and y is assigned to new y. And that's it. That's the complete definition for our point class for now. And on the right-hand side, I'm going to put some application code and see how things work together. Okay? One thing to note, remember we briefly talked about this keyword last time. This simply means, imagine that this is only a class, which is a template. At runtime, you're going to instantiate this class into multiple instances. Every instance might be P1, P2, P3, P4, etc. Depending on which object you're trying to use to call the method. When you say P1.moveUp, it's going to be different from P2.moveUp, even though you're calling the same method, because the context objects are different. Okay? So implicitly, I'm going to use a different color here. Whenever you talk about, you can see we have y here, and whenever you talk about, you can see the parameter is called u. It does not clash with the attribute name. So here, implicitly, you really have this dot y. So being able to figure out where you can put this is going to help you understand quite a bit, okay? Quite a lot. And similarly, you can see over here, the x here is this dot x and this dot y. So whenever, in every context where you can put this, that means you're really referring to the attributes of the current class, okay? So this is from the definitions point of view. Let's see how we can use them. Hopefully things will clear up. So now let's just define another class. Okay, I'm going to use green, okay, just to differentiate. Let's say we have a class over here. I would say point tester over here. Point tester. Okay, and then you have your usual main method here, and I'm just going to ignore the parameter here. Okay, let's see what we can do. Let's do simple things just to review. If you say point P1 is assigned to new point, and over here I'm going to say 3 and 4. Let's review what we said last time. What this will do, you can actually decouple that into 3 different steps. First of all, when you see the first step, which is to declare some variable called P1, and P1 is going to store address only. However, it's not really any arbitrary address. It should be the address of some point objects. So it's going to be P1 at the runtime. This is how I'm going to draw. I'm going to say P1 over here is going to point to something, but at the moment, not yet. Okay? And for step number 2, if you look at this part over here, we're going to create in the memory some objects. If you refer to the course notes, they talk about memory diagram. So in that way, you got more precise view of the memory. But for understanding over here, we don't need it to go that far. Okay, okay, let's see how we can draw this. Basically, if you want to draw an object, this is how you draw. Draw a box over here, and then put the name of the type of the object. In this case, that's point. Okay, and then how many attributes do we have for the template? We have 2, x and y. Okay, so over here you have x and you have y over here. Okay, so far so good. However, you can see that over here we are trying to call this point constructor, right? So let's refer to where the definition is. The definition is exactly over here. Okay, so now you can see you got 3 here, you got 4 over here. That means we are trying to apply the definition on some specific inputs, 3 and 4. I'm going to replace this new x by 3. In fact, every occurrence of nx should be replaced by 3. So 3 over here as well. And then 4 is going to replace every occurrence of ny. 3 and 4. So far so good? Okay. So what's going to happen next is somehow I remember one of you actually asked me the question, how can the compiler figure out if the current context is P1? It's because P1 is really here, just on the left-hand side of the assignment. So Java compiler can just figure that out. Okay, it's easy for the computer. Okay, so now, here, what's really important is this, because P1 is the context object we are talking about. So let me just put context object here. And so we're going to replace every occurrence of this, which is the context objects, by P1. P1 here, and P1 here. So now, we somehow replace every unknown in the definition with what's known in the runtime. So now, nx has been replaced by 3, ny has been replaced by 4. This has been replaced by P1. So now we can do some precise updates on the memory. So the updates, there's 2 steps. First step, P1.x is assigned to 3. When you refer to P1, it refers to the memory address that is stored in P1. When you say P1.x, it is going to go to the x field of P1. Right? So when you say P1.x is assigned to 3, we simply put 3 over here. Right? And then when you say P1.y is assigned to 4, it's going to put it here. And of course, finally, when you put the assignment there, it's going to link both things together. Something like that. Okay, just a quick review of what we did last time. Okay, let's create another object. Okay, let's create another one. Okay, let me just say if I have point P2 over here is assigned to new point, let's say 6 and 8 over there. Right? So we're going to follow the same procedure again. So let me just draw the final diagram first of all. Somehow we're going to have P2 over here. It is somehow eventually going to point to some objects in the memory of the same type, which is point. So we have point here. And since it's the same class, so the attributes are the same. So we also got X and we also have Y. So now the way we are going to instantiate the X and Y here would be the same. We're going to use this particular point constructor. However, since the inputs over here are different, used to be 3 and 4, now it's 6 and 8, right? So it's going to be different. So now I'm going to use, again, a different color here. What about pink? So you can see that we're going to call this the same constructor over here, but now nx would be 6. So I'll put 6 over here, 6, and also 6. And ny would be 8. So you put 8 here, 8 here. And what's remained to be replaced would be this, because now we talk about this P2 over here. So that's the new context objects. So I'm going to replace every occurrence of this with P2, and this will be P2. If you try to read the pink version there, it's going to be this. We are trying to apply the same definition, but just that the inputs are different and the context objects are different. So now what we will do is follow the same two steps. We'll say P2.x is assigned to 6. So P2.x is assigned to 6, and then P2.y is assigned to 8. So that's how we initialize two different objects of point class. Yes?
So when we replace like P1 with P2, so the memory of P1 is stored in a different memory allocation today. It's not replacing the value.
Which one? You mean the which?
We have P1 and P2, so P1 is being replaced by P2.
What do you mean replaced by? We don't have that yet.
6 and 8, which
6 and 8, right. So you can see the second line over there, when you say point P2 is assigned new point 6, 8, right? So we are creating a new object in the memory, which is completely separate from the P1 object, right? So this is somehow what we are talking about over here, right? And then we'll say the way we're going to apply the updates is going to be similar, except that the context object is now P2 rather than P1. So we're going to follow this P2 over here. P2.x is here, P2.y is here. That's why you will go to the corresponding slots to update, right? Good, very good. Okay, let's now see something a little bit new for today. But the idea is very similar. Again, every time you're trying to create an object or to make a method call, either for accessor or mutator, the context object is always the most important thing. Okay? Context object is really the central idea for object orientation. So let's try to understand this. So now, let me put some new line here in the application code. So I'm going to do, let me say blue. Okay? And let me just erase this, so you're going to extend a little bit. So let's say we're going to say P1 dot, let's say, move up. I would say 2 over here. I'm going to put a second line there. I would say P2 dot move up. And then I'm going to put 2 as well. So basically, these two lines are identical, except that the context objects are different, right? So the common part are move up 2, move up 2. And the different part is you got one of them is P1, the other one is P2. So here you have P1, here you have P2. Okay, that's how you see it. We're going to call the same method with the same input, but the context objects are different. Let's see what's going to happen here. Okay, let's have a look at the first line. When you say P1.move up, okay, so we are calling a different method. Let's see which method we are talking about. When you talk about move up here, so that means we're talking about this method here in the point class. Agree? Okay, good. So now we have input argument here too. Let's do the same replacement. So every occurrence of U is going to be replaced by 2. Similar. So now I would say in the case of the method call, the situation is even more obvious than constructor. Because now, if you look at the method call, to the left of the dot is the context objects. So now we know that this should be replaced by just P1. Okay? So now we're going to replace this just by P1. Okay? So now what that update really means is when we say P1.move up with 2 in the client code, in the application code, that means we're going to apply the definition for move up in the point class. But every occurrence of U is replaced by 2. And every occurrence of this is replaced by P1. So we're going to have P1.y plus equal 2. Right? So now if you look at P1, P1 is over here. So P1.y plus equal 2. So what does that mean? So that means we're going to replace this by plus 2. So that'll be 6. That's what we did. We kind of move P1 from 3.4 to 3.6. That's what it does. Are we okay so far? Just for this method call. Okay? So let's try to do the second one. The second one is, again, is going to be done in the same way because we're calling the same method move up. So now, the context objects is different. It's over here, P2. Okay? So now, but the input just happens to be the same. It doesn't have to be, but just happens to be. So now we're going to replace every occurrence of U just by 2 again. I'll put 2 here and 2 here, the pink, the second one. Okay? And now what about the context object now for this? It should be P2, right? Since we're talking about the second line. So now we're going to replace this by P2. So now it would be no confusion for the Java runtime to know which update to do. So now for this particular update, we're going to do P2.y plus equal 2. Right? So P2 is over here. P2.y plus equal 2. Let me just use, again, a different color here. So we're going to increase from 8 into 10. That's what it does. Okay? So you can see calling the same method with the same input may have different effects because the context objects are different. Any questions about this? I think it's really rather important because the way you understand doesn't matter how, just give me one moment. Doesn't matter how complicated the method is. Every time when you're trying to call a method in Java, basically you just got to use a dot notation. You got to say some objects dot some method. That's in principle the case. Once you figure out what the context object is, and once you figure out what the inputs are, you can just do the replacement and apply. Raymond.
So it turns out the y value for like the instance when you consider the object. We do p2.y like print.
Yes, you do. Yes. Yeah. Let me add another page. So let's just make sure everybody understand the code here. Okay, and then we can do something to illustrate. Okay. I want to say a little bit more about this example here. Okay. So let me just add a new page. So now we pretty much know how the code is defined. So let me just write some application code just to illustrate more. So now let's say this. Let me just rewrite this. I will say point P1 is new. Let me do slightly differently. Okay? If I say point, and then I will say 3 and 4. This one is really the same. Let's not draw the diagram just yet. I will just test your understanding, and then I'll draw the diagram to show you at the end. And then we have another object here, point P2. And then I would say new. Point 3 and 4. Okay, so somehow you can see I deliberately try to initialize the 2 points to be the same. However, be careful. Since I got 2 different new keywords, that means there are 2 separate objects on the memory. Okay, they are somehow independent. They just happen to be the same. Okay, so now, first of all, let's do something simple. If I say print p1.x, and then I'll say print and p1.y. I'll just say p, print, and then that can be confusing. Let me just say print. If I also say p2.x and p2.y, what should be the value? Okay, first of all, what should be p1.x? 3, very good. p1.y, 4, right? p2.x, 3, and then 4. Good, very good. So far, so good. Let me just draw a dividing line here. Let's do something a little bit more complicated. If I say P1 dot move up, and then I would say 4, and then I say P2 dot move up 3. Okay, and then I'm going to ask the same question here. If I say P1 dot x, P1 dot y, P2 dot x, and then P2 dot y. Think about it for a moment. What should be P1 dot x? 3, I agree. What about P1 dot y? 8, 4 plus 4, right? 8, very good. P2 dot x? 3, good. Now, what about P2 dot y? Very good, very good. So far so good? Okay, very good. Wow, very good. One more thing. Okay, separate. Let me just put more code here. Continue from there. So let's do something here. If I say P1 is assigned to P2, and then I would say P2 dot move up 2. P1 dot move up 3. And then the same question here. Okay. Now, any idea? 311, 311. Okay, I heard one answer. I heard. Okay, okay. First, what's P1 dot x? Just take a guess. It's okay. I'm gonna draw a diagram. Don't worry. It's okay to be wrong. P1 dot x, 3. Okay. You know what? You might agree. Somehow we didn't change x at all, right? What about P1 dot y versus P2 dot y? P1 dot y? I heard 7. I like that answer because that's wrong, so I can illustrate. Okay. Okay, what about P2 dot y? I heard 12, okay. So somehow we want to, well, this is a possible answer, maybe not in the lab test, because in the lab test you can just enter into Eclipse and then execute the code, right? That's not what I want. This can be a good question for final exam. Okay, let's figure that out. Okay. Which one? Oh no, we're gonna test it out. Yeah. Okay, let's see. Let's see. Let's see. Okay. First of all, let me draw the diagram here. First of all, let me just draw the dividing line here. I will use maybe just green. First of all, let's do the first one. When we first initialize P1 and P2, so we have P1 here, which is, guys, I know you're excited, but please, please. Point over here, x and y, initially 3 and 4. And then we also got P2 over here, and initially also 3 and 4, right? X and y, 3 and 4. Okay. Okay, so far for the first region. So now when we say P1 dot move up 4, we're going to change P1 dot y and increment by 4, right? Okay, so it's going to be incremented into 8. And then when we say P2 dot move up 3, we're going to change P2 dot y only, and we're going to change that to 7. So far, so good. However, what's really annoying is this line here. P1 is assigned to P2. Let's think about what this is trying to do, because if you draw the arrow in the wrong direction, the answer will be wrong as well. So now, when you say P1 is assigned to P2, that means we're going to store some value into P1. And what we're going to store into P1 is the address that is currently stored in P2, right? So that means after this assignment here, P1 and P2, they will store the same address, which is what P1 is currently storing. Okay. So now let me just make some annotation here, and then we'll see how that looks like in the diagram. So this one here, store P2's address into P1, which means in a way P1 is going to point to somewhere else, which i.e. P1 is going to point to wherever P2 is pointing to. P2 is pointing to here, and P1, rather than pointing to the old place, it is going to point to wherever P2 is pointing to. So make sure you really know why I draw this arrow this way rather than the other way. Okay? Any questions until this point? That's really critical. Once you get this sorted out, the rest is actually easier. Are we okay? Okay. So now after this, P1 and P2 are basically referring to the same objects. As I said last time, this is something called alias, which I will talk about hopefully later today. Okay. So now, when we say P2.moveUp2, right? In this case, we are using P2 over here. P2 is the context object. So P2 is referring to this object here. So P2.moveUp2 is going to increase P2.y, which is here, from 7 to 9, right? And then when we say P1.moveUp3, even though I'm using a different context object, but because of this line over here, P1 and P2 are referring to the same objects. So when you say P1.moveUp3, it is going to say P1, which is currently also referring to this object here, right? This is P1. Okay? So we're going to increase this further from 9 to 12. Okay? So now, what should be the answer here? P1.x, P1.x, which is 3. And you should notice that P1.x and P2, which is here, P2.x, they are really referring to the same field, right? So they should be the same. So these two are right. Now, P1.y. So P1 is here, .y should be 12, right? So this is not right. So this should be 12. And P2.y, which is also 12, right? Is referring to the same object. So P2.y is also 12. Questions? I hope it's not too bad, right? Okay. No questions? Should I give you more challenge?
Yeah, more challenge.
Okay, more challenge. Well, sometimes, when I make up some challenge, on my feed, so maybe something that doesn't make sense. Okay, that's fine. Let me just ask you something very easy. This one here. I'll start fresh. Otherwise, you'd be confused. So now let's try one more thing. Okay, just one more exercise. If you have, again, point P1 is assigned to new point. And then we have, by the way, this is something called aliasing. So what you really have to do is keep track of the addresses. Okay? So now let's see this. Again, we got 3 and 4. So now we have point P2 and point. So we have 6 and 8. This is what I want you to try to think. I say P1 is P2 as before. Now I say P2 is assigned to P1. Okay, after this. Okay, let me insert some line here. Okay, so I say P1 is assigned to P2, and then I say P1 is move up. Let's say just 2. Okay, and then after I assign P2 is assigned to P1. After this, I say P2 dot move up 3. Okay, 4 lines. So I'm going to ask you basically what I really want you to understand is how the x and y will change throughout the lines. right? That's something you should really try to understand. Okay, I'm gonna just draw a diagram to show you, right? Okay, again, I'm gonna draw a diagram here. Let's start from the very first line. When I say P1 is assigned to new, so I'm gonna have P1 over here. It's going to point to some object over here, and then it's gonna be point, and we have X and Y. It's gonna be 3 and 4, okay? And then we got P2 over here, and then it's going to be of type point as well. We got X and Y, and then we got 6 and 8. So far, so good. Now, when I say P1 is assigned to P2, that means P1 is not going to point to wherever P2 is pointing to, right? So this is the critical one, first of all. That's something we studied already, okay? So after this, we're going to say P1 is not going to point to this object anymore. We're going to point to here. Okay, so now, if I say P1 that move up 2, right? So now you can see that P1 that move up 2, we're going to change 8 to 10. So now after this line, so P1.x will just be equal to P1.x will just be P2.x, right? Because they refer to the same objects. They will just be the same, right? They're both just 6. And also P1.y will just be equal to P2.y, and they're both just 10. That's what's going to happen after this line, okay? Now, what does P2 is assigned to P1 do over here? This one is a little bit tricky. Well, somehow it's a bit artificial, but let's try to understand what it is doing. We are trying to say, starting from here, we're going to say P2 is not going to point to wherever P1 is pointing to. In that case, are we going to change the arrows? No, because they are already pointing to the same objects, so it doesn't really matter. Okay? So now, after this one, we don't have to change the arrow in any way. Okay? They're still pointing to the same objects. So now, when I say P2 now move up 3, we are really talking about the same object as before. So P2 that move up 3 is going to P2 over here, talk about this object here, is going to move up by 3, which would be 13. Okay? So after this line over here, so P1.x will still be equal to P2.x, in which case will still be 6. And we have P1.y will still be equal to P2.y, but now they are 13. Okay? As you can see, the best way to really figure out how exactly things go, let's say you don't have the computer beside you, not to rely too much on your mind, maybe draw some diagram. That's why I'm showing you how to draw the diagram. Diagram is easy. Every time you have an object, draw a box, and with all the attributes there, and with the values filled in. And every time you have some reference assignment over there, draw some arrow. Okay? Any questions before I move back? Are we okay? Good. Good. Okay. So now that's about this one here. I'm sure I'm covered some later points as well. Okay, we talk about context objects. You can also compare this one. Okay. So now you can see. Okay. Also about this reference here. Okay. So now you can see that over here, basically, this is how we define every time when you have x, if x does not clash with the parameter, you can certainly put the implicit this, which means you're referring to the attributes of the class. Okay, that talks about the context objects. Okay, yes.
Can we put a point, but can we still use double x?
Double x? Yes, that's a good question. Let me just talk about this right away. Maybe that's simply on the left. Okay, I'll just talk about that now. So the question was, if I try this, thank you. Thank you. Good. If I try something like this, let's see what's going to happen. I still have the point class over here. Okay, let me just watch the time, make sure I'm okay. Okay, so now we cast point over here. Now we still have double x, double y, double y. The question was, if I try to do the let's say constructor point over here, I used to say nx and y. In that case, they do not clash with the attribute name, so that we are safe. But let's say if you put something like this, double x, double y, just like that. Somehow x matches x, y matches y, okay? And now, if I try to do something like this, if I say x is assigned to x, y is assigned to y, okay? Let's say I do that. Is this really right or wrong, right? Wrong, right? Remember, when we talk about utility methods, there's something I said is called shadowing, right? It's exactly the same situation again. So we do have shadowing in this wrong version. So how does shadowing occur? So basically now you have two references over here about x. I'll highlight them. You got x over here. You also have another x over here. So now what we really want to know is which x are we really referring to? Yellow one or green one? The yellow one, right? Because somehow you can think about the green one as like the sun, right? Somehow it's being shadowed by the yellow one, okay? So now if you do this version here without any further fixed, this x refers to the x here, this x also refers to the x here. Apparently that's not what you want to do because you're only changing the input, which has no effects. What you really want to change are the attributes of the objects, okay? So now, how can we fix this? Yeah, that's why I'm pretty sure you know the answer. So the way you fix this is by somehow using the this keyword to disambiguate. You want to say, rather than, I know that x and y have been shadowed already, so I'm going to disambiguate by using this keyword. It should be the context objects dot x. Okay, that's what I'm going to do. So this is the wrong version here, and I'm going to show you how you can fix it on the side. So this is wrong because of shadowing. Because of shadowing. So what about the right version? The right version, I'm going to put it here. Let's say you really don't want to create any new names. Myself, I also don't like to think about new names. You can simply say double x, I still keep that over here, and double y over here. This is what I used to do, which we know is wrong. But now, I know that for this x over here, I really wanted to mean this x over here. That one's fine. And also, the y over here, I really wanted to mean this y over here. That one's also fine. It's the x and y on the left-hand side of the assignment I want to disambiguate. I want to say they should refer to the attributes. So now what I can do is use this. I can say explicitly this dot x and this dot y. Okay? Let me give you just a little bit further example to this. Let's say this is how you define the code. Now, when you say, let's say point P1 is assigned to new point. Let's say 5 and 3, like that, right? So now, in this case, we are going to call this constructor here point, which is here. Now, we're going to replace every occurrence of x by 5 over here, right? So it's going to be 5 over here, and also 5 here. You can see because we got this dot x on the left-hand side, so I don't replace that by 5. I don't, because I know very well. The left-hand side means context objects dot x, okay? And then, similarly, I'm going to replace every occurrence of y by 3, over here by 3. Now, as we said before, we know that the context object is P1. So now we can replace this by P1. Let me use a different one. So over here, I can replace this one here by P1, and this by P1. So that really boils down to something similar. It will be P1.x is assigned to 5. And P1.y is assigned to 3. That's exactly what we expect to happen, right? So this is, I would say, the most common use of this, one of the most common uses. There will be some other occasions there where you may want to use this for some assignment, which I will show you, okay, a little bit later. But this is maybe the easiest one to understand, okay? Any questions? No? Okay. Okay, let's go back to the slides. So I think you pretty much understand everything about this. Okay, again, so the context object is really important, right? Depending on what the context object is. So I'm gonna leave this to you. Basically, I've said that already. Okay, this is exactly what you just asked, right? If you have to use this over here to disambiguate. Okay, so this one is already covered, so we can go a little bit further. Okay, this one is really easy. This one is wrong, right? You can see, for example, in the person constructor there, I say name and name. So somehow the shadowing effects is not going to make the correct behavior to happen. So how do we fix it? Adding this. You got to say this.name is assigned to name. This.age is assigned to age. And similarly for the mutator method over there. Similar. Okay. So now, so far so good? Okay. So I think there are many things. Let me just go to the point. I want to talk more details. So I think in the class, I'm going to just focus on maybe mainly the point class. But I got another parallel example over there called person. So person basically has maybe age, nationality, weight, and height. These are very similar to what you did for lab number 2. So I will assume you can just follow that very easily. Okay. So I'm going to mainly focus on the points and see what we can do. Let's do some quick exercise over here. Okay. Let's see how we can do. Let's do some very simple method. Okay. Just to re-emphasize our understanding. Okay. So you can also see for the person example there, I also show you how you can see the different steps for creating the objects, right? So that's how you decompose the assignment into 3 different steps. The same idea. Okay. I don't need to just repeat. Okay, so now let's go to Eclipse quickly. I want to show you what kind of methods can you write. Let's write some interesting methods there. So this is basically just downloaded from the course webpage. So this is where we left off from last time. So we got point class over here, and we already got the constructor here. I already used this last time, but I didn't really explain that thoroughly last time. But hopefully now it's much better. Okay, so now let's say we want to define. So the definitions for mutator and accessor are exactly the same as before, right? Mutator simply means you do not return anything, just returning void. Accessor means you return something that's not void, right? So that's the same as utility classes. But now the only complication we are adding here is we got context objects. That's the only complication, okay? So let me show you some. So let's see some mutator methods. Let's do something simple here. So what we used to do, let me just show you what I really want, and then let's see how we can program that. Let's get a little bit more complicated. At page below. Let me just draw you the idea on the iPad. Let's say this is our 2-dimensional plane. If I have already some P, for example, some points, and it has X and Y, okay? This is what I want to do. I want to have a single method which is going to somehow give me 2 inputs. For example, let me show you how I'm expecting to use the method, and let's see how we can program that. So now if I say P dot move, let's say, I'll just say move over here. Okay, so what does that mean? So now I'm going to give you 2 input over here. 2 integers basically. If I say move 3 and then -2, so what does that mean? You can think about conceptually it's going to be 2 steps. I'm going to move the points, whatever the context object is, first of all vertically with some units. If the number happens to be positive, that means I'm going to move up. If the number is negative, that means I'm going to move down. Okay, so the first one is vertical move. And the second one is horizontal move. I said up. Oh yeah, wow. Sorry, I'm just contradicting myself. That's good. You guys really pay attention. That's good. Okay, first of all, horizontal, which means we're going to move to the right by 3. And then we got vertical. In that case, we're going to move down in this case. Now, just to test your understanding, what does it really mean when I say p.move and then 0 and 0? What does that mean? Stay the same, right? Good. So now let's say for this particular one, we're going to move to the right by 3 units. So that's going to be x plus 3 and then y. And then the second step for the method is going to move down by 2 units. And then it's going to be still x plus 3, but now it's going to be y. You can think of plus minus 2. Something like that. Conceptually, that's what we want to achieve. But now, how do we program that in Java and test it using JUnits? Okay, that's our challenge. Everybody understand what the requirement is, right? Okay, let's try. Horizontal and vertical, I will remember. Okay. Okay, so now mutated method here. So now I'm going to say public void move. So it's going to be horizontal units. And this is going to be vertical units, okay, just like that. You can document using Java doc. Let me just save time. So now, how do we do that? So basically, you're going to, first of all, how would you suggest? How do we move horizontally? This dot plus equal HU. So now, question for you. Is this keyword here necessary? Why not?
Because it's implicit.
It's an implicit. However, you can see, I can tell you that, I'll put that in the code as well. In this case over here, this keyword is necessary because we do have the shadowing, because the x over here clashes with the parameter x, right? We do need that. On the other hand, somehow for this method here, both parameter, their names, do not clash with the attributes. There's no clashing, okay? Okay, I will mention that here. Here, because of shadowing, we need this. Here, maybe I'll just put a little bit at the next line. So over here, no shadowing. So this is optional. Okay, it's up to you. I'm going to do one, but not the other. So now, how do we move vertically? We can say, yeah, let me just finish this. You can say y plus equal vertical units. Yeah, question.
My question is, this is optional in this case, but is it bad practice to put it in the
I wouldn't say it's a bad practice, but I would say it's actually quite good if you're in the beginning, because somehow you really know that you're trying to do some assignment to your attributes, right? Mm-hmm. And also, as you know, the way I try to explain how the method call actually occurs at the runtime, when you have this, you know very clearly what you should replace this by, the context objects, right? Yeah. Okay, very good. So now this is the method there, and then let's test that very quickly, and then we'll see some accessor method. So basically, I can give you some additional exercises maybe next week after the lab test. So I can give you some more complicated program to play with, and like what we do for the additional exercises, I can stay longer in some later Tuesday or Thursday. We can go over a solution. Okay, that's how that can work. Okay, so let's test this very quickly, and then we'll go on. So now what we want to do is go back to test point over here, and let's have a new one. Okay, public void, let's say test move. Okay, point P1 is assigned to new points. And we know very well it's going to be simply just, okay, let's just say assert true. P1.x equals 3, and P1.y equals 4. Okay, so let's try this. If I say P1 dot move over here, and then I can put, let me just put the one that I put on the iPad. I'm going to say 3 and then minus 2. I want to show you again how to use the breakpoint and debugger, because now we are now talking about not utility classes. We talk about objects and instances. I think that using the debugger is going to help you quite a bit later on. Okay, let's try to see how the debugger is going to work. Okay, But let me just put some assertion here, and then I'll show you how to use debugger. Assert true. So now p1.x assert true, right? So p1.x is going to be, so we're going to move to the right. So it's going to be 6 and p1.y. And we're going to move down by 2 units from 4 to 2. That's what we expect to see. Thank you. Okay. Now let's just run the test. Okay, it passes, first of all. Now let's see how we can verify that. So now I want to show you again how things will go in the debugger, right? The way I show you in the diagram matches how debugger is going to show you what's happening at the runtime. So now I want you to look at line 50 very carefully again. In line 50 there, we are trying to call the method called move in the point class. And the context object there is p1. Okay, let's get it very clear. And then we're going to later step into this particular method to the point class. Over there, since now we are trying to talk about this particular method call, so over there you will see that this will be replaced by just p1, right? Just the point p1. Okay. Okay, let's see what's going to happen. Okay, let's now I put a breakpoint there so you can press on this button here. Click on that. I'll say yes. Okay, now I pause over here. So now let's see something interesting here. So there are 2 panels again. I want to show you both of them. So now you can see that under variables, if you don't have that, you can simply go to Window and Show View, and then you have variables over there. And the other one you really need is expressions. I'll show you both in just a moment. Okay? So now you got variables, you got expressions. I don't have expression at the moment, so I can add it. So I can say Window, Show View, and then expressions. So now I got both of them. Now for variables, you can see there's a p1 over here. So p1 is the object of type points. Okay? So now just for your information here, if you click on p1, it shows you something like this. You can think of it as the address of the points, the objects. Remember, p1 doesn't store the whole objects. It stores the address. Right? So that's sort of like the address. Okay? So now, what's more interesting is you can expand the object to see how it looks like. Remember, the way I show the object visually is by drawing box. It's pretty much like that. Okay, let's now try. I'm going to expand. You can see this triangle over there upside down. You can expand it. You will see P1 has X and Y. Right? It got exactly 3 and 4 as we learned because we got this constructed here, 3 and 4. So X and Y got 3 and 4 over here. Okay? So what's so good? Now we want to see what's going to happen after we say p1.move over here. So what I will do is I will step into this particular method to see how the p1.x and p1.y will be changed. Okay? So what I would do is I'll say step into. I do that. So now you can see that now I'm in the context of not the test class anymore. I'm now in the point class because I stepped into the method, right? So now I'm in the point class. You can see over here, I'm now at this point here. Now, if you look at that, you can see this over here. So this is P1 because we said P1.move, right? If you expand it, you can see P1.x is still 3. P1.y is still 4. We haven't changed them yet. Okay? So now, if you go to expressions over here, you can do something here. Any expression that will make sense. For example, you can say this dot x at the moment is 3. Hasn't been changed yet. You can also say this dot y is 4. Okay? And what about HU and VU? Horizontal units will be 3. If I type VU here, that'll be -2. Okay? So now, what's going to happen here is we're going to say this dot x, which is 3, is going to be incremented by 3. So now I want you to watch very closely this dot x. Currently, it is 3. Once I say step to the next line, it's going to become something else. Should be 6, right? Because I'm trying to move horizontally by 3 units. If I say step, again, you can see that has become 6, right? And then, now what's going to happen here? currently this dot y is 4. And now I'm trying to move vertically by -2 units. In that case, after this, it will become 4 plus -2, which will be 2. Right? Now you got 2. Right? That's how things are being changed. Okay? So we move horizontally first and then vertically next. Okay? So now I can stop. Okay? Over here. Any question about this? I hope it's still manageable, right? Yeah? Just calling some mutator method here. Guys, if you're completely lost, feel free to say. It's okay, right? Because if you don't ask me a question, I will assume, this is usually what I say to my students. If you don't have questions for me in the class, I will have questions for you in the test. Right? That's fair, right? Seriously, no questions? No? Okay. Watch the recording. If you got questions, feel free to come to my office hour. So far, I got only students from 3311, not too many from 2030, right? Well, it's okay, but if you really have questions, don't be shy. Okay, let's now do a accessor method. So that's about mutator method here. Every time when you do a mutator method, you simply just change some attribute value, okay? So now let's do another one, which is accessor method. So now I'm gonna go back to Eclipse. Let me, again, talk about the idea. And this one is gonna be interesting. I think this one, you have done the implementation part pretty much in your lab number 1. Okay? So now, let me just use the same diagram, or maybe just use a different one. This is what I want to do. I want to do an accessor method that is going to return some Boolean value, either true or false. Okay, I'll give you some example here. Again, let's say we have the 2-dimensional plane. Just make sure we understand terminology. We understand this is this is called the first quadrant, right? And this is called the second one. That's called the third one. This is called the fourth one, right? First, second, third, and fourth. Now, I want you to do something like this. Given the points with x and y, figure out which quadrant it belongs to. How about we do that? So it's going to return an integer. Let's do a Boolean version first, and then we do an integer version. Let's try both. Okay? So now I want to do, for example, something like this. Let's say P is over here. Okay, that's a P. Let's say, if I say P dot is at first. Sorry, how do you spell that? D-R-A-N-T, right? Something like that. Okay, quadrant. Okay. Doesn't matter. Yeah, you know what I mean, right? You can fix that for me. That's fine. Okay, so this one should be true, right? At first. This one should be true. Let's say P1. On the other hand, if you say, let's say P2 is over here. If I say, calling the same method, P2 dot is at first quadrant there, that should be false. Let's do this one first. Okay, this one's easy. Think about how you would do it, right? For this one here, basically based on the value for x and y for the context objects, we're going to decide. So what's special about being in the first quadrants? All positive, right? Right? X should be positive and y should be positive. Let's do that very quickly. Okay, this one's very easy. Let's do this one first, and then I will show you something that's slightly more complicated. So now let's do accessor method here. Okay, let's say public, let's say now not void anymore. Let's say Boolean is in first quadrant, okay? So just Q. You know what I mean here. So now let's do slightly more verbose version. What I can say is, I say if it is the case that this dot x larger than 0, should I say n% or vertical bar? And right, it should be both. And this dot y, larger than 0. Yeah, one moment. In that case, I can say return. Let me just say this. Let me do a very verbose version, and I'll show you how to simplify that into one line. So Boolean, let's say answer. Answer is true. Otherwise, the answer is simply false, and return the answer. Okay? Yeah, question. Huh? Let's not worry about 0, 0. Let's say 0 doesn't belong to anyone. Okay, let's say that. Okay, so let's say it has to be strictly positive, right? So this line is pretty much understandable. I hope this is understandable. So now I can simplify this into a single line. Because I know that somehow the answer over here depends on the truthfulness of this Boolean expression here, right? Why don't I just return that Boolean expression right away, right? So what I can say is, I can say return, let me just copy and paste this line here, and then that's what you will see. Okay, so that will do. It doesn't matter which version you choose. If you want to write a bit more verbose version for you to understand, that's absolutely fine. Okay. Question about this method here. Okay, let's do some very quick test, and then we go for the little bit more complicated version. Let's go back to test over here. Let's say, let me just copy that. Test is at first quotient. Okay, let's say we got 3 and 4. We can say assert true. P1 dot is first quotient, right? Because now currently it is 3 and 4. So now we think it should be true, right? Let's try that. Okay, so now let me create another point. Point P2 is new. Let's move that to maybe second quotient. Let's say -3 and then 4. It's going to fail one of the conjunction, right? So now, if we say that, it's going to fail for sure because it's not true anymore. So what you can say is, that's P2, sorry. P2 over here. So now I can say assert false, right? It should be false. Okay, so what's so good? Okay, so now let's give a slightly more difficult version, but this one will be fun. This one, I'll leave that as an exercise for you, okay? Now, let me tell you how I think it should work, and then you'll figure out how to write it. Let's say, over here, let me just reuse this example here. I want to have a method called get quotients. So P1 dot get, I'll just say Q, okay? You can spell it right in your code, get quotients, okay, over here. So now, it's going to return an integer. It can only return 5 possible values. It can either be 0, 1, 2, 3, or 4, okay? So now, in this case, P1 is exactly in the first quotient, so it's going to return 1. So now, let's say if I simply give you the origin, let's say O. If I say O dot get quotient over here, it should return 0, right? You kind of see my idea. Let's just give another one. If I have P3 over here, if I say P3 dot get quotient here, that should give you 4. Okay, I'm going to put a signature in the Eclipse, and I'll let you finish the rest. Okay, either going to be 0, 1, 2, 3, 4. Okay, and then we'll go on. So now let's go back to point here. So this will be your exercise. Okay, let's say public integer get quotient over here. So now, for now, I just say return -1, just make it compile. Okay, you know what the requirement is. Yeah, finish that as soon as possible. You can show it to me during the office hour or ask me in email. Okay. Any questions about, so now so far we talk about constructor, we talk about mutator, we talk about accessor. Right? So we talk about all the 3 kinds of things. And then we're going to continue with the slides. See more interesting example. I think there are many parts of the slide you can just go over. Right? We have covered basically many things already. So we talk about method here. So this is just like a general view of a method. Every method, you can think about it as a black box. Right? So think about, I'll just give you one example very quickly. Okay? So now, over here, how can you think of a method? So basically, you can think about a method first of all, is a block of code. A block of code. Another way to think of it is a black box, which means when you're trying to use other people's code, you don't necessarily know every details about the method you're calling. For example, if you say math dot square root, you don't necessarily know how exactly to implement that, right? It's a black box to you. And the black box is how you can think of it. So let's just make one example. Let's talk about the get quotient method you're going to write. To me, it's like a black box because I have no idea how you're going to implement that. So first of all, I just put a name, get quotient. And in this case, it takes no input. Okay, I'll just say no input here. And then it's going to return some integer. In some way, there is an input, which is you got to give me the context objects. Depending on where the context object is, it can be origin, it can be P1, it can be P2, etc. Right? Let me give you another example. Let's say we have another one. Let's say I want to calculate another exercise for you, and then I will use that to draw another black box. Your exercise as well. Somehow this exercise got a solution in the slide somewhere. Try not to cheat. Okay? Try to do that by yourself. I'm pretty sure it's somewhere. I forgot where. Okay? Let's say I'll give you two versions here. Let's say here, hopefully that can clarify your understanding. I'll explain to you what the difference is. Let's say get distance. I'll simply say point other. Okay, I'll just say return -1 for now. Okay, I'm going to give you another one, and that one there is going to be the same name, but it actually has two parameters. I would say P1 point and P2. Let me put some description there, and then to see what I'm expecting you to do. Okay, so here, return the distance between this, which is the context objects. I'll explain it to you in just a moment. This and other. Okay? And now another one. Return the distance between this and P1, this and P2, and P1 and P2. Basically, you figure out the distance of the triangle, basically. Okay, I'll show you in just a moment. I'll show you. So you can see that these two methods have the same name, but the way I describe them, they're going to be implemented quite differently. Okay, I'm going to explain to you how you're supposed to use them. Okay, let me just go back to iPad, and then I'll show you. Okay, so now let me just go back there. Yeah, I think I got enough space. So now let me put it here. Okay, I'll put it in the small box here. Let's say I have P1 here, I have P2 here, I have P3 here. Okay, let's try. When I say P1 dot get distance, and then I pass P2 over here. What does that mean? That means I'm trying to figure out the distance between other and this, P1 and P2. So what I really want to figure out is basically this distance here, P1 and P2. Okay, this distance here. So this is basically P1 dot get distance P2. That one's easy, right? Just between this and other. The second one I want you to do is a little bit different. I say P1 dot get distance. And over there I pass 2 points. I have P2 and I have P3. So what does that mean? First of all, you can see that, let me just use a highlighter here. Let me use a different color. P1 is here. P2 is here. P3 is here. it's going to figure out the sum of 3 distances. So you can see that P1 here is this, right? It's the context objects. So you're going to figure out, first of all, between P1 and P2, plus between P1 and P3, and between P2 and P3. So 3 distances. Okay. Is it too hard or? Oh, okay, it's okay. Yeah, you're gonna return the sum of the 3 distances. Yeah, the sum. For example, let's say between P1 and P, it's like the length of triangle, basically. Add them all. Yeah. Mm-hmm. Okay, hopefully it's not too difficult. Give it a try. Okay, and let's go on. Okay, so now when we talk about method here, you can just draw a black box. Okay. So now what I can do is over here. Let me just go back there. Now let me just do one more black box for you. So you can think about if you say get distance. You can think about you're given P1 over here, you're giving P2, and then you're going to return the distance between P1 and P2, right? So some integer. Okay, that's how you can understand the method. You got a block of code which will take some input, including the context objects, and then return something. Okay. Okay, so yeah, that's just something general, just to revisit our term, signature. So again, whenever you talk about signature, that means the return type, the name, parameter types, etc. Right? Okay. Okay, so now one thing to note, whenever you declare, let me illustrate this to you. It's about the scope. Okay? When we talk about scope, we talk about public, private, things like that, right? It's a different concept of scope. Oh, it's very easy. Okay, let me just illustrate that to you. Okay, let me use a new slide. New paper here. Oops. Okay, let's have some artificial class. If I say class A over here, and then let's say if I declare integer, doesn't matter which type it is, integer I over here. And now let's say I have some accessor over here. Let's say it's going to return a Boolean. Let's say it's, I would say, accessor method. Okay? And then it's going to take nothing as input. Okay? Another one, let's say over there I declare another variable called integer j. Let's say it is equal to just 3 for now. Let's say got another method here, which will be returning some integer. Oh, no, don't return anything. Let's say it's a mutator. Void mutator method. Inside, let's say we have some integer k, 4. Okay, let's talk about the scope. When you talk about I, you don't say I, well, usually you can say I is a variable, but that's way too general. You would say that I is an attribute of the class, which means every method in this class here can refer to the attributes, every method. Okay? So now, if you try to say, for example, refer to I is assigned to j multiplied by 2, this is okay. Similarly, you can refer to I, that's definitely fine. Okay? The scope covers every class. You can also say that I is assigned maybe k times k. This is also fine. Okay? You can see I here, the scope covers the entire class. On the other hand, if you try the following, let's say, let's just continue from this method here. If I say k is assigned j plus 2, you cannot do that. Because now j here is not an attribute name. So in the method there, you can only refer to either an attribute or some parameter or some local variable. But now you can see j, apparently you may be thinking about this j over here, but no, you cannot do that. The scope of j It's only within that method there. Okay? So now let me just try to do some coloring here. So basically this is kind of the scope of J. This is the scope of J. So now over here you cannot do that. Okay? It's going to be a compile time error. Okay? Just about scope. Similarly, in AM over there, you cannot refer to K because the scope of K is only within the mutator method MM. Okay? Similar idea. Okay? Okay, 2 minutes maybe? Okay, so now we can go over that. Yeah, basically everything is what we have said. So this is just like a summary to tell you constructor, mutator, accessor, etc. Okay? So now, maybe I'll stop here. So let me tell you what's going to happen here. So on Thursday, we got a lab test. I'm going to put some notice to you. So basically, it's going to be starting from 4 p.m. You will be given roughly about 17 minutes to complete a task. Okay, I'll be giving you some instruction to let you follow. But here's the thing. When you go to lab test, don't put your mobile on the table. You should really put your mobile in your bag and put it underneath your leg. Okay, and then as Professor Ma mentioned in the email, you can bring a piece of blank paper, you can bring a pen, but don't put anything on that. It's not allowed for this time. Okay? And then I'm going to take a 5 minutes break now. If you cannot stay, feel free to go. That's okay. I'm going to record it. Otherwise, we'll resume in about 5 minutes.